day, ladies and gentlemen. It is Thursday, August 4th, 2022. I'm here with Marco Lababa, CEO of Adamera Minerals, Martin St. Pierre, the geophysical consultant and all-around handy guy, um, who's got control of most of the data on his machine. We're just going to have a quick conversation about what Adamera has been doing and is and will be doing in the next little while. I mean, I think they've probably been a bit quiet, but they have been active. They've got a couple of holes down now. They're going to keep drilling for at least a couple of months, probably longer. Uh, and I'm going to get Mark to give us a quick overview of where the work's going to happen this year, and then the drilling that's been going on here. First couple of holes is near Lamefoot. They'll move the rig to Buckhorn. So we're going to deal with Lamefoot where they've already got a couple of holes, and then we'll talk about some of the targets at Buckhorn that they're going to hit. So can you just give us an overview of, because obviously the adage is the best place to look for a mine is next to a mine. So the inference obviously is that you're looking for something next to Lamefoot that looks like Lamefoot and something next to Buckhorn that looks like Buckhorn. So starting with Lamefoot, where you just put a couple of holes down, can you tell people, what was Lamefoot? What type of deposit was it? What did it look like? I mean, what are you looking for to try to find something that's, you know, a look-alike, if you will?
You bet. Thanks, Eric. Yeah, Lamefoot Mine was discovered in the 90s. It was a pretty high-grade deposit, 8 to 10 grams, almost a million ounces. It was found originally by Echo Bay, and that was mined up until probably the early 2000s. And it's on a property just adjacently and to the north of us. And it's located along a limestone clastic contact, and it's relatively sulfide rich. It can occur with magnetite, or it can be with pyrite and purite, just depending on where you are in the system. Okay, so before I get into that, I'll just show you where it's located. This map here just shows all of our projects. I'm going to talk about Lamefoot just in this area here, which is part of our Cook Mountain project. And then we're going to go into Cook Mountain, and Martin's going to go through a lot more of the geophysical data just to show you how we're developing our targets. So a little bit of a close-up here on where Lamefoot is here. You can see the Lamefoot mine. This candy cane striped property is what we call Lamefoot South. Now, got a few targets there. Here, I don't know if you can see that. I'll move this over here. On this target, here's our target. We drilled that, and we hit 4.7 grams per ton gold over 2.7 meters. And within that, there was a 10-gram interval over about 3/4 of a meter. Okay? Let's take a closer look here. That's what it looks like. You can see it's within the limestone, very close to the limestone clastic contact, as I mentioned, and heavy sulfides, so massive sulfides. And this is probably where you get the 10-gram material, and then you got shoulders that keep it, give you a few extra meters, and you're still around 5 grams per ton.
Right.
So what we wanted to do this year is go into this area, try to determine orientation of that mineralization. This is a blind deposit, which means it's not exposed at surface. It was purely a geophysical / geochemical discovery. So that's our objective. What we're looking for, this is a really interesting, it's an old slide that we found on the internet. It's from Lamefoot. This is the Lamefoot mine, and you can see Lamefoot mine's about 1 million ounces of gold, and it occurs in multiple pods. And that to us is a really exciting prospect, because we see that on the Lamefoot South project. So these are either pods or cigar-shaped deposits, but they add up to say about just under 1 million ounces. Now, here's where we've done our drilling. This is some geophysics with geochemistry. Our first intercept is in here. We've now stepped out, not very far, but just enough to try to develop an orientation. And what I like about this area is that's the area we're testing now. We're hoping that we've got a multiple of these, so we're looking at other features that are similar. So you've got the geophysics, you've got gold values up to 330 ppb, We continue to look at these, and this is a big one here, and this is something we'll want to test if we can prove the basic concept for that deposit a little bit further up to the north. But in this particular target, you've got some size based on the geophysics, but also you're looking at gold values in the soil up to 0.5 gram. So pretty interesting target.
Okay, but the spot where you just drilled 2 holes, it's up at the
Yeah, right up there.
top of the map, the north end. The PL6 that's the one that had 5 grams over 3 meters. Can you tell? I mean, obviously you don't have assays; you barely finished drilling a hole, but can you give us some idea? What you saw and what you think it tells you in terms of potential orientation, that sort of thing.
Yeah, so as I mentioned, we wanted to determine the orientation. So we put in 3 holes in total now. We can determine some basic orientation of that. The first hole we drilled this year, we hit the mineralized zone. It wasn't. It was an intercept, which was great. The second drill hole we put in was we hit it a little bit deeper, and it was a much more intense intersection, a lot more sulfides and wider. So it's almost twice the thickness and a much more massive pyrite and massive sulfides. So pretty nice.
And with 3 pierce points, you can do a solution to determine, hopefully, basically the dip and the strike of a planar surface. That's what 3 intercepts get you. The 3 point
And we're not really
solutions.
100% sure that it is a planar surface. We think that it is, like a rod or a cigar-shaped body potentially that has
Right.
a strong plunge to the northwest. And again, with a series of those, you can develop your tonnage. That's the concept for this project. And
Okay. Now,
hitting it twice or hitting now 3 times is really exciting for us.
okay. Now that you've done this, I mean, and it sounds like you hit a pretty nice intercept. Who the hell knows what the gold grade is? It's gold
Yeah.
properties, but you'll know when it comes back from the lab. But you told me that you're going to be moving the rig to Buckhorn. You just drilled what sounds like a nice hole. You've got that really nice target at the south end, the lower end of the map. What's the reasoning behind moving to Buckhorn now?
Right. So we've drilled those 2 new intercepts. We want to get the lab results. We want
Right.
to also, we've got now a really good intercept down hole. We're going to drop a electrode down the hole on the massive sulfide zone, and we're going to electrify that and energize it, and then we'll do something called mise a la masse, which will help direct where that sulfide body or that mineralized body is heading. And when we come back and test that, we'll have much more information on where it's actually heading and giving us a much better chance of hitting it. And if
Okay.
there
Can
is,
you give
if we have
give us a
multiple,
1 minute? Can you give us a 1 minute missile Moss for dummies, Martin? I mean,
yeah,
what are you doing with this probe?
Yeah, it's basically you're putting a rod down in there, and it's like, it's like almost like doing a resistivity. What you're going to do is you put one rod far away from the hole, and you have a wire connected to that, and you have another rod that's in the hole, and you actually put the rod in contact with the mineralization. And then what you do is you pump current into the hole, and wherever the mineralization lead, if it's connected, it's going to form a volume of voltage. So then what you do on the surface, you take measurements of the voltage, and whatever direction the mineralization follows, this voltage is going to follow it also. So if it's like a pod, a very circular pod with a bit of a tail in one direction, that might, suggest that it is a plunging pod. Or if it has more lateral extent, then we'll see that also. So it's going to give us more information as to direction, size, and help us, possibly design the next drill hole.
Okay.
yeah.
And
And in the
I think part
meantime,
of your decision is also based on field season at Lamefoot relative to Buckhorn. I mean, they look pretty close together on the map, but the weather's quite a bit different.
You nailed it. We want to get to buckhorn fairly soon because buckhorn has a definite season. It gets pretty snowy by November.
Right.
And here at Lamefoot South, you can drill all year round. Last year, we drilled here up until probably the 20th of December. So,
Okay.
we only shut down for Christmas. So you can basically drill here all year round. And that's,
Okay.
yeah, it's certainly about logistics here in the sense, but also coming back with geochemistry and a mesols and moss survey in hand is going to be quite useful for us.
Okay. Well, it
And
sounds like you got one that looks good. That's good.
yeah, we haven't called this a discovery just yet, but I think after we get these results back, if we can show that there's some size potential and we're getting good repeatable grades, we're certainly in the realms of a discovery.
Right. Okay. So
And and
yeah.
if I could say one last thing, this is a
Yeah.
discovery that is about 600 meters from a known deposit. So Lamefoot, don't forget, is just only about 600 meters to the north.
Right.
And it might be part of the same system. We think it's part of the same fold structure. And that being said, we're really, we've got a good shot here.
Okay. Okay. That sounds good. So now you're moving the rig to Buckhorn. Buckhorn, I think, is a little bit different in terms of the model, or maybe if you can give us an overview of, what the Buckhorn mine was, um, and by inference, if you're looking for more buckhorns, what should a target look like if to have the potential of being, a buckhorn lookalike or twin or whatever.
Yeah. So first of all, this is a bigger property. This is 36 square kilometers. It's got some size to it. In the central part of this property is something called the Buckhorn Mine, which was mined by Kinross. Kinross still retains that land as a reclamation site for them. The Buckhorn Mine was a precious metal bearing skarn. Skarns, typically in this part of the world, are magnetic because they've got magnetite and purite. And when you get into these mineralized zones, they're quite sulfide rich, making them good conductors. So again, what two of our big focuses here, mag and electromagnetics, as well as geochemistry on the surface to see if we can put, to see if we can get some kind of support on the surface for gold. So if we get a beautiful mag anomaly, for example, and a conductor, we'd like to see some geochemistry on the surface, either in rock or soil, to support that it's a gold target. And we've got a number of targets, and when we get Martin to focus in on some of these various targets, you'll see exactly why we're using these different techniques and just see how effective it really is.
One thing I want to point out and ask you about, this claim area, more or less, was held by Kinross for quite a while. Kinross, and I think I know what they did wrong because I looked at the permitting statement. Sometime back, they tried to permit an insane amount of stuff in one permitting go. And I think when you first staked this, there was probably some skepticism because people knew, but Kinross knew, those guys, they couldn't get drill permits. That's kind of why they walked away. But I've known you a long time and you've been working this area a long time. And I've always pointed out to people that you're very good at sort of splitting these things up and dealing with the three different permitting, um, bureaucracies that you have to deal with. And as it happens, you have in fact had a fair amount of success so far permitting, and I think you're expecting more permits now. But you have quite a few permits in hand for a number of these targets already, right?
That's exactly right. So in this area here, if you can see my cursor, a lot of
Yeah.
BLM. The targets on the BLM ground are permitted. Up here would be state, and we've got a
Right.
number of targets on the state land that are permitted. We've got some more BLM down here, and then the majority of the project is U.S. Forest Service, and we're working on U.S. Forest Service now, and we're confident we'll get it, but we still haven't got it just yet.
Okay. But you do have a large number of targets, or you do in fact
We
have
have enough
permits.
targets to start, absolutely.
Right. Okay.
And
Do
one
you
of the
want to
things
go into? Yeah.
one of the things that we've done even this year, we had targets last year, but this year we really needed that summer to get on the ground, verify the various targets that we've developed, and we've applied a lot more targeting tools. So last year we did a lot of ground mag and Martin's going to show you exactly how effective that was. We did a small block of EM last year. We absolutely saw value in that data. So most of the project this year has been covered in VLF, and that was a major undertaking. And one of the things that we've developed, and we really started using, developed a usage for it here is SP, or self potential. And that was some of the data that you would have been looking at Lamefoot. We liked it there, and we started using it here, and we've really had good success in developing targets. We don't know quite what it means just yet, but certainly some really good targets, and Martin will definitely go into that. And one last thing, if I could just say, Eric, about the Buckhorn mine. That was a pretty good sized mine. It was 1.3 million ounces of gold, average grade of about 12 to 13 grams per ton. And it's the only known deposit in that area. And I really believe these types of deposits occur in clusters. And we have a data set now that is absolutely, I would say, quite incredible. Data that we purchased from Kinross, which was probably about 20 years worth of work. And the data that we've done in the last 2 years has really come together to give us an amazing data set. And we're quite proud of that. And we're happy to go through this right now on screen.
Okay. So can you go through maybe the first 3 or 4 targets that you're definitively think you're going to be drilling here?
Sure.
Yeah, start off with VTEM 15 if you could.
So what's very important to understand, so we were just looking at the overall picture that Mark showed us. We can see on both of these images this kind of like outline in the middle. Here it's very clear, and that's the Kinross block that still belongs to them. And this
Right.
area right in here is where the mine was exploited, where the mine exists. What we see on the left side is a helicopter-borne VTEM magnetic and electromagnetic survey that was flown. And basically what we see here is the image of the magnetic field. A lot of very important geological features can be seen here, but the point is that we went in there and we thought, okay, this is great, this is really nice data, but we would like more resolution, more detail, to see what's going on, to see structures if they exist, to have much more information. And that's possible, but it has to be done with ground magnetic data. So basically we had crews running through the terrain with lines that are spaced at 50 meters with the continuous measuring GPS supported mag units, and they walked all of this property. And again, if you need a scale for this, the scale of this property is basically from south to north. We are looking at 9.5 kilometers. So it gives you an idea of how many 50-meter lines you could have had. And now you can see between these two maps that we're looking at the same data, but with much, much more resolution. And also what we see that's very important is the skarn characteristic. That's what the Buckhorn mine was contained within skarn. And when Mark says it has magnetite or pyrrhotite, what that also means is that it has a signature to it. And what is this signature? It's a signature of high frequency magnetics. And I'm going to show it to you right now, and it's going to stand out. For example, this area over here is a good target area. We're going to look at it later. Right now, I'm going to just take a quick look at this area here where we have a target called VTEM 15. That's going to be our first drill target in the area. And I'm just going to zoom into that area right now, and we'll see it. So this is, to your left, the magnetic data of the airborne system. And to your right is the ground magnetic data. You can see that there are features that are similar, but the amount of detail that you have is amazing. And all of these blue and red sections, that's skarning. It's a signature. It's a signature of what skarns look like. So as you travel throughout the property, there's many other areas that have this skarn signature. All this area over here, which is another primary targeted area, is skarn. We believe. I mean, we haven't drilled it, but actually this has been mapped, and there's mapped evidence of scarring. So we've basically been able to define areas of scarring activity with the magnetic data to a very high level of precision, and that's been helping us to target the various anomalies or anomalies that we're interested in. Also, the VTEM data collected electromagnetic data. So this we're going, and this provided a lot of targets for us. The Buckhorn mine itself has an electromagnetic signature, and we have a number of other electromagnetic targets that are distributed throughout the property and actually form the basis of some of the targets that we're going to follow up on in the future, and that we have followed up already. Again, the VTEM 15, for example, which is going to be our first target area, is located over here. And here we have a classic VTEM airborne EM response. So that was one of the targets that we decided to investigate in detail. So clearly there is an electromagnetic component associated with the mineralization in the Buckhorn mine. So we wanted to get additional electromagnetic information, and we decided to deploy VLF EM methods, which is a method that uses transmitters that are operated by the government, and they're very sensitive and they're easy to collect. And from that, we collected this data set over here. So what you see here is the results of the VLF EM survey in the property. And these bright red zones all represent conductive zones. Now, these conductive zones can be related to sulfide mineralization, but they can also be just faults or contacts between two rocks of different resistivity characteristics. So basically the idea was to get this data and try to combine them with the geochemistry, the drilling, and many other characteristics. Well, for example, that the VTEM 15 anomaly, which is again is going to be one of our first drill targets, this is what we got out of that. We have a coincidence between the VTEM EM and this VLF target. So what we did with that, and what we've done with a number of properties, is we wanted to find another methodology on surface, easy to deploy, that might give us an idea of actual close to surface sulfide concentration. So we decided to test SP, but we started with the SP on the Lamefoot area, and it worked well over there. What SP does is basically, if you have sulfides relatively close to the surface, because of the water table and the contact of the water table, it dissolves the sulfide grains and it creates batteries. So you can just basically measure the voltage on the ground to see, to pin down pretty precisely shallow sulfide mineralization. So I'll show you an example of what came out of that work. Here we go. We're going to go take a look at it over here. And it's basically over here. So now we focused in to the area we've just been looking at. And that was the VTEM anomaly associated with the VTEM 15 anomaly. This rectangular shape is actually an EM plate derived from using Maxwell EM modeling software. So that is the location of a deep-seated, relatively flat-lying, strong conductive body. And here what we have as contours is the VLF anomaly. And what you have underneath that in the colored grid over here, that's the SP data. So the SP data shows itself as a low voltage, and you can see the semi-coincidence of the VLF and the self potential and the VTEM. And now we look at the numbers over here. These vertical numbers over here, that's a soil sample collected by Kinross at 7 grams. It's 7,030 ppb, 7 grams gold, 0.3 grams gold. Over here is a rock sample worth 12 grams of gold, 0.3 grams of gold. These drill holes were drilled by Kinross. And the thing about the drill holes that we see here is that they were drilling east-west, but everything is actually going east-west and needs to be drilled north-south. And in reality, this hole over here has an intersection of 1.7 grams. There's another trend actually a bit more subtle here on the SP that goes down over here and crosses. Well, this hole actually has an intersection of 1.3 grams, almost there. But again, they're drilling obliquely. So we're going to drill a hole right through here. It's going to intersect this VTEM plate, cross the VLF and SP anomaly. So basically what we have here is we have almost 4 levels of coincident information, starting with the VTEM EM, then and the mag also. So I wanted to show you the mag. This thing we have to see here is the mag. And as I was talking to you before, the signature of the skarn environment is this high frequency dipolar, bright red colors in close contact with bright blue colors, which represent an area of high magnetic activity. And this is what it looks like over here. So here's the mag. So here you have the VLF, and if you recall, the SP was trending across over here. All of these high reds and low greens are high frequency, high levels of activity, characteristic of skarning and our interpretation. So we have EM with the VTEM, we have EM with the VLF, we have sulfide detection with the SP, and we have mag dipolar environment, and we have a lot of geochemistry in the area, and we actually have holes that were drilled in the past that did intersect some gold, but we believe were drilled in the wrong direction. So it's almost 4 to 5 levels of confirming data coming together to bring up a hole like this, or a target like this. So, well, we're pretty encouraged by this. I said, this is really great. So what are we going to do next? So we go back and we, of course, looked at some of the other anomalies that might be of interest. So if we, so basically we did the VTEM 15. We've just basically looked at this tiny little area within the whole system. There's other ones that are of interest, particularly, of course, you know, you're always looking for size, right? I mean, this is not bad. This VLF trend is at least 400 meters long. So that's encouraging. There's another VLF trend here that's of great interest to us, which is basically almost, we're looking at almost 1.3 kilometers long. So we wanted to see, well, is this VLF and SP coincidence just a one-off lucky break, or is it something that happens all the time? Is the SP going to help us differentiate from some of these VLF conductors that might be barren of sulfides, or ones that have sulfides? So basically, one example is this VLF 2019, and I'll just show you the results. And these, we just did little 3 lines of SP right over the heart of the anomaly to see if we had the right kind of information, because at the same time, these anomalies are actually in a skarn-like environment. See all of these high lows over here? Well, that's that skarn signature, that skarn signature, that skarn signature. And this VLF 19 follows this skarn signature in kind of an east-west pattern. So we went to that anomaly and we surveyed it, and I'm going to bring up this data right.
While you're doing that, Martin, I want to just point out the VTEM on the other map is also coincident with that and is supporting the VLF.
Yes, there's actually, and see, the thing is that the VTEM was flown east-west. So any anomalies that were going east-west are parallel to the flight lines, and sometimes it might be real anomalies, but they look like they're leveling problems, right? So anyways, just to go back to where I was, we're going to go look at BLF. Hold on, I want to find it here. Here we go, 16, and this is 19. So basically what we're looking at here, the contours that we're looking at is the axes of the VLF anomaly. And what we're looking at is 3 lines of SP, and we have an anomaly right here. Well, it's right perfectly coincident with the VLF. And then if you look at the magnetics, the ground magnetics underneath that, what do we get? Dipolar activity. So again, we have an area of magnetic dipolar activity characteristics of skarn, an east-west VLF conductor, and a coincident SP anomaly. So that's what we're working on. There is one example where 2 examples where we did some VLF and some SP, I mean, over a VLF anomaly, and in that case, it did not react favorably, which was encouraging to me, because if we can use SP as a way to prioritize these VLF conductors, that would be a great tool. And that's what we're trying to prove. And we have supporting evidence. So again, if we go back to the general map and we look at the anomaly that I'm talking about, which is a fairly long anomaly, which was called VLF9. And it basically is located over here with a strike length of almost 750 meters. So we went in that area and we did some SP, and basically it came out negative. I'll just show it to you very quickly here. It was over here. There you go. So basically this is this is the profiles of the VLF, and this is the of the VLF, I'm sorry, of the SP. It's just chaotic. There's no big, nice, low anomaly in it. And when you look at the gridded data, it's just very chaotic. There's no coherence with it. The SP anomaly goes through there. There's not much association. It's all very weak. And the magnetics are not as interesting. There's some dipolar activity over here, but it's relatively quiet compared to what we've been looking at the other places. So in this case, in our opinion, VLF9 has become now a very low priority if it's not completely off the list. Maybe another area I'd like to show you, basically following this same idea, is a new area that actually was kind of interesting, because that was an area that most of this mag data was collected last year. There was a little section down in here that was not collected, and it was collected at the beginning of this year. And we realized that, oh my gosh, look at all of the skarn activity in this area. So if you zoom into this over here, you can see that this area here, which is a prime area for us that we can go in another time, we see now that it looks like it just curves into that. And we have some really significant VLF anomalies. We have VTEM anomalies over here, VTEM 5 that we see over here. We have this VTEM 5 anomaly, and we have some extremely strong VLF conductors. This whole area is quite strong with VLF conductors. This is a very strong VLF conductor, and there's actually some very strong supporting geochemistry in this area with rock samples that are going from over a gram and a half to almost 30 grams from the Kinross sampling in this area, plus workings and other features. And all of it is into an extremely active skarn-lark environment. So we put a couple of lines, 3 lines over this anomaly to see if it would kick with respect to the SP. And as a last one, I'll show it to you how impressive it can be. I'm going over here. M27. I'm going to be there soon. And this would be the one. Okay. So basically, this is the SP data. This is the mag data. This is the VLF contours over here. And these actually is the SP contours. So you look at the mag data, again, strong dipolar activity, and the actual SP is the strongest we've measured here. It's almost a volt. And for SP, a volt of anomaly is enormous. Its coincidence is extremely good, and but unfortunately, there's very little geochemistry. But right next door to this one, which is basically what we call VLF 32, we put some other lines over here, and we got not quite as strong, but still compelling coincidence. But in that area, there's some very, very nice geochemistry, and it is basically looking like this. This sample here is 36.9 gram rock sample. Here's a 1.69 gram rock sample over here. The contours over here are the axes of the VLF. The blue numbers is the SP anomaly. Even this weaker anomaly over here, we have some activity over there. So this whole section, of course, and then you see the very strong magnetic dipolar activity associated with these anomalies. So basically, that's the model. We're going for skarns, just like the Buckhorn deposit. We have multiple layers of data from the geophysics and the whole data set that we have from Kinross, drilling and geochemistry. And we're able to come into areas where they've drilled because they had some stuff of interest, but they didn't have this kind of data to drill in the right direction. So we have a lot of areas where they have drill holes, they drilled there for a reason, but we have targets there that they didn't drill. So that's really encouraging because we have all of this data to bring together.
And it really creates a great screening tool because the mag in itself is showing potential for sulfides and magnetite.
Yeah.
The conductivity can often pick up things like graphite, which we don't want to see. And when we see a conductor with strong magnetics, then we can, to a certain extent, try to rule out the possibility for or the likelihood of graphite.
Yeah.
And
okay, so in terms of the drilling, you're just moving the rig here now. What are you hoping to get done in the next, whatever, 2 or 3 months? What do you think you can do in terms of, because I assume this is kind of similar where you're going to put a hole or two into each target and just see what you get before you kind of blow your brains out on one target or another, unless there's something super obvious, obviously, in the drill hole.
yeah, we're hoping to drill about 8 to 10 targets in that kind of fashion.
Yeah, because this isn't an area, the whole Cook Mountain area, it's not an area where you're likely to get super obvious in terms of what the gold grade might be. You just know what the right host mineralization is, and you put it in the lab and move on.
Unless you have VG, but exactly, that's not very common in this kind of
You
stuff.
don't see that very often at all.
Okay, so you got one, you got the target at Lamefoot South that looks like you hit something that sounds pretty good. Waiting to get gold grades. You're going to hit 8 or 10 targets here. I would stress that, as always, Adamera is very efficient, very frugal when it comes to spending. So you do, in fact, have the budget to do 8 to 10 targets on your own without having to worry about going back to the market or anything. So you've got 8 or 10 shots here. This is kind of what, although obviously it's at Buckhorn rather than Cook Mountain. I know this is kind of what you're trying to, it's sort of the scenario you've been trying to set up for years, really.
Yep.
Is where you went into a season with a long list of targets. So you're going to hit all of them with a drill.
Yeah. I mean, this could put us into a situation where we've got 2 separate discoveries, one at Lamefoot South and one here on Buckhorn. And
or multiple at Buckhorn.
yeah, I don't look too far ahead. I'm just really excited about VTEM 15, and I think that's a great target for us. It's got a lot of potential. It's got so many layers stacking up and just giving us a lot of confidence.
Okay, and the rig's going to be there any
Later
day,
this week.
basically.
Yeah.
Okay.
Yeah.
Okay. Well, I mean, there you have it. I mean, Adamera, like so many other stocks, is not carrying a big valuation. It sounds like you got a nice hole, hopefully, fingers crossed already at Lamefoot, which will give you something to chase. And again, Lamefoot is, because it's gentle slope, it's open slope, so facing mainly, you can pretty much drill there year round. In the meantime, you're going to be hitting 8 or 10 targets at Buckhorn. there's you got a lot of shots here, and any one of those could turn into
Mhm.
something. And obviously, I think if you really got lucky, I guess, on one of these targets at Buckhorn, and you weren't out of season, like if you got a hole or two back that were pretty hot, you'd probably just drag the rig back and see if you could build on that. Would that be the idea?
Yeah, for sure. Yeah.
Okay.
I say the drilling season is up until November. If we hit something, we can keep drilling.
Right.
You can do a winter drilling program here.
Depends on the areas too. Some areas more than others, even within the property, obviously, right?
That's right.
Yeah. Yeah. North facing, south facing, that kind of thing.
Exact elevation.
Right. Yeah. Buckhorn's got a lot more elevation than Lamefoot does.
Absolutely.
Okay. I mean, I think your shareholders will be happy to know that you have not, in fact, been doing a Rumpelstiltskin. You have, in fact, been at work quite busily for the last 2 or 3 months, and you already got a couple of holes down, and now you're moving to Buckhorn. And I, I'm going to reiterate again that there were a lot of targets that I think I know Kinross really like, because Kinross is trying to target. They were trying to permit a massive and ridiculously massive, honestly, exploration program. Then that was probably their downfall. They tried to bite off too much at once. But unlike them, Mark has in fact succeeded in getting drill permits for a large number of targets, and he's working on other permits for another set of targets, all on the Buckhorn project. So he's really got first crack at a lot of these targets. They haven't really been hit properly before, because the former guys had permitting issues, and Mark's having a lot more success than they did getting drill permits.
And we've got more data as well to really
Yeah.
help hone ourselves into these targets. A lot of these targets they've got everything, including geology, geochemistry, and geophysics. So it's a little bit. We try to take the risk out
Right.
of those targets.
Really.
Okay. Great set of targets. Mark Colababa, Martin St. Pierre from Adamera Minerals, AGZ on the venture, and DDNNF, I think, OTC in the US. It's great to see these guys drilling again. It's great to see them drilling 100% own stuff. Uh, you know, I like the look of these shots. These are nice targets. So fingers crossed, everybody. Let's see what we get. Thanks very much.
Thanks,
Thank
Eric.
you.